Hello everyone. Let us discuss some of the numericals based on electric potential. The first numerical is a charge of 108 microcoulomb is given to a metallic spherical shell of radius 1 meter. The first question is to calculate the potential at the surface of the shell, and the next question is to calculate the potential at a distance 0.1 meter from the center of the shell. So it's a very easy question in which we know that whatever potential is there at the surface, the same potential exists at any point inside the shell. So at a point 0.1 meter, since the radius is 1 meter, so the potential will remain the same, and the value of potential will be 1 by 4 pi epsilon naught q by r. In the diagram also it is shown there that the value of potential for the value of small r, which is equal to capital R, that is up to the radius, that is up to the surface, remains the same, and after that the potential decreases exponentially. So the potential at the surface will be 1 by 4 pi epsilon naught q by r, and the values are given. So you have to put the values only. The r is 1 meter radius, charge is given, so you put the values 1 by 4 pi epsilon naught q upon r. So you have the final answer 972 into 10 raised to the power 3 volt. Now similarly, the second part of the question is the point is inside the spherical shell, so the potential at the point is exactly equal to the potential at the surface, and the value is 972 into 10 raised to the power 3 volt, the same answer. I hope this is very clear to you. We move to the next question. A charge is given of 8 millicoulomb and located at the origin. Now you have to consider and find out the work done in taking a small charge. Another charge is given -2 into 10 raised to the power -9 coulomb from the point P to the point Q through the point R. So you see here a charge Q 8 millicoulomb, that is 8 into 10 raised to the power -3 coulomb, is given, and a charge -2 into 10 raised to the power -9 coulomb is to be moved from the point P to the point Q through the point R. Now we know that the value of work done is calculated by the charge into the potential difference. We have derived the relation earlier also. So potential difference we need to find between Q and P, final position and the initial position. It doesn't depend on which path is chosen. So the potential difference between Q and P will be VQ minus VP. That will give you the potential difference into the charge which has to be moved, which is given by -2 into 10 raised to the power -9 coulomb, will give you the total work done to move this charge from P to Q. X-axis, Y-axis and Z-axis are given, and accordingly the values of the location of Q and P are given. So charge at the origin given 8 into 10 raised to the power -3 coulomb, charge which is to be moved Q dash -2 into 10 raised to the power -9 coulomb, distance of the point P from the origin RP 3 into 10 raised to the power -2 coulomb. For the point Q, the distance from the origin is 4 into 10 raised to the power -2 meter. Now the work done is calculated by the charge Q dash into the potential difference. The potential difference VQ minus VP. The value of VQ is 1 by 4 pi epsilon naught Q by RQ, and VP is 1 by 4 pi epsilon naught Q by RP. So we taking out the common terms, we have this relation, and the values we put accordingly which are given in the question, and the final answer which comes out is 1.2 joules. I hope this is also clear to you. We move to the next question. A cube of side B is given, and a charge of small q are present each in all the vertices. You have to determine the potential and electric field due to these charges at the center of the cube. Now from all the corners where the charge Q is placed, this center is equidistance. So what we are going to do is we'll choose a charge and we'll find the potential at the point O due to that charge, and then we have to multiply it by 8 because 8 charges are there, all are equidistant, so all of them will be having the same potential at the point O. So we'll multiply the quantity which is obtained for the charge at H with 8 so that we get the final answer. Now potential is a scalar quantity, we all know, so this distance is important. This is the same distance for all the charges. So when we consider here HC, we have a right angle triangle HFC, where HC square will be given by HF square plus CF square, so according to Pythagoras theorem. Now this HF can also be calculated by using the Pythagoras theorem, where the triangle HGF is a right angle triangle, at G being the right angle. So HF is the hypotenuse and will be given by root 2b. So when we are calculating the value of HC square, so it will be HF square, that is root 2b square plus this b square, so it is 3b square. So HC will be given by root 3b. So HO is half of HC, so it is root 3b by 2. So the distance R from the charge to the point O is root 3b by 2. So therefore we calculate the potential for a single charge 1 by 4 pi epsilon naught Q by R. The value of R we have already calculated, root 3b by 2, and we multiply it by 8 for all the charges. So this is the total amount of potential that we get. Again, it was asked to find the electric field also. We all know that for any symmetrical number of charges, the electric field at the center will naturally be 0 because of the symmetry. I think this is clear to you. Any doubt, you can post the doubts. Thank you.